Okay, now we are already able to get the geometry of our Tensegrity structure from our Grasshopper component. But at the beginning of this video, we said that our goal was not only to get the geometry, but also to run a simulation with Kangaroo of our actual Tensegrity structure. So in order to do that, we need not just the geometry, but also the physical properties of its elements, such as the cross-section, pre-stress force, and so on. So in order to get those data, there are basically two different approaches. We can either add additional parameters, additional output parameters to our Grasshopper component, but in that case, we would end up with a really messy Grasshopper definition with many parameters and so on and so forth. Or instead, we can define our output parameters of our Tensegrity, let's say our Tensegrity elements, not as pure geometry, but as objects with different properties, such as, of course, the baselines, but also the cross-section and other parameters attached to those elements. So that's what we're actually going to do. So, of course, the first step to start defining our objects is to define the classes that contain the properties and methods of those objects. So we are going to start with our strut elements or compression elements. So let's create a class for that. So before in the first chapter, we actually created the classes inside of the same, let's say, file here. But since now we are going to be creating several different classes, we are going to rather use different files for each one of them. So we have to come basically here to Tensegrity, and then we do right click, and we click on add and new class here. So we are going to call this new class Tensegrity bar, because remember, this is for our compression elements or strut elements. So let's add this class. Here we are, and we can see that we are getting a different file here in the, let's say, Solution Explorer. So the first thing we have to do is to set this class as public class. This is really important because otherwise the Grasshopper component will not be able to access the content of this class later on. Okay, so now let's define the properties of our class like that. These are our, let's say, properties, that's right, but in this case we are not going to add like a get and set functions because we are not going to add, let's say, additional functionalities to them. So it's okay if we do it like that. And we need, of course, the rest length of our bars, because that's important for the simulation later on. And we need also the area and the young modulus to compute the stiffness of our bars. And finally, we need the geometry of these elements. And we are going to define this geometry as lines, as we did before. But now I'm getting an error here. And of course, if I click here, I see that the reason is because I'm not referencing the Rhino geometry library. So I just click here to this suggestion from Visual Studio. And now I can see that this reference has been added here. And now I'm not getting any error anymore. Okay, so now we have our properties. So the next step when we're creating a class, you already know that is the constructor. So here you go. And that's right. So we are basically taking these arguments and we are assigning them into the properties of our Tensegrity bar class. Okay, and now let's start adding the methods of our Tensegrity bar class. So first, what we are going to do is to create a method to convert this object into a string so we can get the information attached to this object, let's say the properties, whenever we connect this let's say, parameter or Tensegrity objects in Grasshopper with something like a panel. So what we are going to do is to define public override void, and then this is going to be to a string. And yes, whenever we call this method, we are going to convert this into a string. So what we are actually doing here is to say, okay, return a string format, and here you already know how this works. So basically, I mean, we already saw this in the first chapter, but we are going to add some information into this string. First, we are going to say, okay, this is a Tensegrity var, and then we are going to, let's say, show the properties attached to that particular object. In this case, we are going to say, okay, the res length is the res length. And remember, in order to specify numeric values, or rather variables inside of this string, we have to first add this $ symbol and later on include this variable inside of this kind of curly brackets. But in this case, it's not a variable, let's say, but a property. So we are doing it like that. And then I just wanted to display 2 decimal places. So I'm doing it like this. And of course the units. And we are doing the same for the area and the YAG modulus of these elements. Okay, so then the next method that we are going to add into our class for our Tensegrity vars is a method for converting this object, of course, into geometry, in case that we want to know the shape of our Tensegrity structure. Because this is basically an abstract object, and we want to get the geometry, so we are going to do that with this method. First, we have to add, of course, the Grasshopper kernel library here, like that. And now we are calling this method, I mean, it's just to geometry, that's the name of this method. It has to be public, of course. And we are going to return a new Grasshopper line, which is going to take this line as input. So yeah, nothing new, and you can, of course, take a look into this constructor in the Grasshopper developer kit. Okay, so, and finally, the last method that we need is, of course, the one that is going to convert this object into our Kangaroo goal in order to run the simulation later on. So, of course, now we are going to be dealing with the Kangaroo library. So the first thing that we have to do is to add a reference to that library. So I've already attached these files into the content of this video, so you just have to download it. So we're going to add a library to Kangaroo, a reference to Kangaroo, and also to the, let's say, the assembly K2 engineering. And I mean, you can also try downloading these libraries from the internet, from the repositories of Kangaroo and K2 engineering, but I strongly recommend that you do it this way, because it's very important that okay, this is complicated, but it's very important that the version of Kangaroo that you are importing is the same version of the library, of the Kangaroo library, that K2 engineering took as reference when it was compiled. So if that version is not the same of Kangaroo here and the reference of Kangaroo with which this assembly was compiled, then you are going to get an error in Grasshopper. So for that reason, I recommend to take these references as I have just uploaded here, and let's move on. So, okay, here we have our references, and now we have to know, okay, but what kind of object do I have to return so that the simulation in Kangaroo can succeed later on. So in order to get the answer to that question, we are going to come to the repository of K2 engineering. You just have to Google K2ing, and then you come to the repository of Cecily Brandt, who was, of course, the developer of this plugin for Grasshopper. So you can either Google that or come to this website. And here, basically, it's she explained everything about this plugin, how you can install it, and so on and so forth. But now what we are going to see is which kind of goal is similar to the object that we are trying to create. And actually, the bar element is the one that we are looking for, because this is basically like a straight element with just compression forces, no bending. So that's what we need. And we can see that he already implemented all the functionality so that these objects can work with the solver Kangaroo. So we just need to do two things to use these objects. First, of course, at a reference to the K2 engineering library, what we have already done. And the second thing is to use this constructor here. So if we use this constructor, I mean, in order to return this kind of object, bar goal object, then we are going to be fine, and we are going to be able to provide our Kangaroo solver with this object, and the simulation should work. So for that, let me adjust that method like here. So I'm going to call this to call object, but again I'm getting this error because I'm not referencing the library Kangaroo solver. This one, which is the one of course that comes from this reference, and it is including the goal objects here. And now I'm getting another error because I'm not referencing the library K2 engineering like this, which of course I'm getting from this other reference. And now we are using the constructor that we saw inside of this bar class and so on and so forth, so that we are returning a bar element that we are going to plug later on into the Kangaroo solver. Okay, that was everything regarding the class for our Tensegrity bars or Tensegrity struct elements, and now let's define the classes for the other elements of our Tensegrity, which are the cables and the supports, of course. So let's go for it. We do right click here, and again add new class. So let's start with our cables, Tensegrity cable, and we'll always have to, let's say, use like singular names for our classes. It's like a convention, and here we are. I hope you remember what was the first thing that we have to do when we create a new class for a Grasshopper plugin, which is of course to add the public keyword. Okay, here we are. So now what I am going to do is to paste the content of this class, because I'm not going to be doing anything new. I just want to get rid of these errors, of course, at the beginning, just by adding the references to these libraries here, Grasshopper, and now Kangaroo, and K2 engineering, I mean, and here we go. Okay, no errors anymore, and yeah, basically it's the same as before. I need the properties for my cables at the beginning. I've just added a new property regarding the pre-stress force. And this is the constructor. This is the function to display information in panels later on in Grasshopper as test strings. And we are also converting this into geometry lines with this toGeometry function. And we are going to be creating cable elements with Kangaroo and K2 engineering, just like before. And finally, let's define a class for our supports. So again, let's come here, add new class, and Tensegrity support. That's right. And we make this class public. And I'm just going to copy the content of it once again. So let me get rid of these errors once again. So potential fixes, I want to add this library, and I need also the Grasshopper library here, and the Kangaroo library, and K2 probably. Yeah, that's right. So we have added these references here. That's right. And now, I mean, here the properties are a bit different because of course this is a support object, so we need the location as a point 3D, and we need to specify the directions in which the support is going to be fixed. And that's it. This is my constructor, and this is the method to convert this support object into a string so that you can display it later on in panels in Grasshopper and so on. And now we have these other methods to convert our supports into geometry and into support goal objects from Kangaroo. Okay, so here we are. I think we are done with our classes regarding our objects. So I just want to point out that it's very important how we are naming our classes. So in this case, these are my classes for my Tensegrity objects, let's say. So I have named them with Tensegrity, with the word Tensegrity at the beginning, so that they are grouped here together. And now we are going to do the same with our components, because we need in this way, what we are going to achieve is that we have a clean and nice, let's say, structure of our Visual Studio project. And now what we are going to do is to come back to our Tensegrity component and we are going to modify it so that the output is not just pure geometry, but the objects that we have just created. So let's go for it. So the first thing, the pre-stress force, is no longer going to be optional because we need this parameter for our cable objects. And now this is the important part, the output parameters. So I'm just going to copy it and comment it. So, okay, so we don't need them to be just geometry, but let's say generic objects. So in order to do that, we need not a line parameter, but a generic parameter like that. And we are going to do it also for the cables and the bursting cables and for the struts or bars and also for the supports. But the description of these elements is going to remain like that. And now, of course, we have to change the definition. So first, we need to assign a value to this, or rather, we have to assign this input pre-stress force into a variable here, which is going to be this one. So let me copy this guy here. This is going to be the parameter number 4 into this variable. Okay, here we go. And now what we have to do, of course, is to change the definition of, so first what we need to do is to define the properties of our, but not that, we need to define the properties of our objects. So we have to come back here again, where that's right, here is where we define our properties here, and let's add the new properties, let's say the mechanical properties of our cables and strut elements. So now what we have to do is to change the definition so that instead of having let's say cables here as lines, we have the actual cable objects. So for that we have to come to this list definition, sorry, and yes, we have to change this so that, for instance, this is no longer going to be a list of lines, but a list of Tensegrity bars, and this is going to be a list of Tensegrity cables, and of course this is going to be a list of Tensegrity supports. Okay, fantastic. So for instance here, instead of adding just a node, let's say a point, we have to add here the constructor, which was new Tensegrity support, and this guy takes first the point, in this case the node, and also this is going to be true because we are going to fix the support in all directions. Okay, like that. So here we go. Of course we need to close the brackets, and we are done with our supports. Let's move on. Then the polygonal cables. This again, this is not going to be just a line, but a Tensegrity cable element. Tensegrity cable, and we need the baseline, and we also need the area, which we already defined here, the area of the cables, and we also need the Young modulus. And I mean, you don't have to take care of that, but I already took the right units so that Kangaroo can work properties. I mean, the units that are consistent with the ones that were defined in the library K2 Engineering. And finally, sorry, we need the pre-stress force. That's right. And we are going to take that from this variable here. Oh, sorry. Or rather from this input parameter into the component, let's say, and here we go. So now, okay, the next we have to change our strut elements. So let's add new, and then this is a Tensegrity bar. And so the first argument is our baseline, like that, and then we need to define the area of our bars and also the Young modulus, again from here. Okay, we are almost done. We just need to add the, let's say, the cable objects for our bracing cables. So again, new Tensegrity cable, and this is the baseline. Sorry, I forgot to close the brackets here. This is the baseline, and now we need the area. Where are you? Here you are, area cables, and the young modulus, like that. Okay, and closing brackets, and here we go. This is the set data list from our list, and I'm getting an error here because I forgot the pre-stress force that I am getting from here, from this input parameter. Okay, so I think we are done, and now we can test our Grasshopper component again. So I'm going to click here in Start Debugging, so that Visual Studio can compile this project and test it with Rhino. But again, now we are going to test our Tensegrity component, but the result should not be just geometry, but an actual list of Tensegrity objects. Okay, so here we are. Now let's get our component, the Tensegrity component. And okay, so the first thing that we can notice is that here, instead of having, let's say, lines as output, we can see this kind of a black polygon or black container, which is related to generic data, let's say. So it seems that it's working more or less, and now let's define our sliders. And now it's not working yet because we also need to provide data for this pre-stress parameter, because you remember that this parameter is no longer optional. But it's in Newton, sorry, so let's say between 0 and 2000, for instance, and let's say 100 or 500 newtons, why not? So here we go, and now we are getting an error because strat elements need to be longer. Okay, that's not a problem. Of course, because of course we need a polygon with more than one side. So now it's working, but if we try to go to Rhino, now we can see that we cannot see anything here, and that's because we are not getting geometry from our component, but we are getting the objects. And you can see that when we click here, we can already start seeing the information of our objects, let's say, but it's better if we connect these output parameters with a panel. And now we can see the description that we created in Visual Studio with the method toString, if you remember. So these are our objects, but as I say, they are just abstract objects. Okay, we can display the information here, but we can't do anything with them. So what we are going to do is to create now two additional components. The first one is going to, let's say, convert these objects, these abstract objects, into geometry so that we can visualize them. And the second object is going to convert the second component, I'm sorry, is going to convert these objects into Kangaroo goals so that we can do a simulation with the Kangaroo solver.